Hi, I'm Francis Campoy and this is Just for Funk. Welcome to episode number 31 of Just for Funk. Today we're going to continue what we were doing in the previous episode 30, where we were talking about protocol buffers. Today we're going to continue adding a layer on top of protocol buffers, which is gRPC. We're going to do the basics of gRPC, and we're going to convert our to-do tool that we had built before to manage our tasks that we need to do, a to-do task. We're going to make that into a server and a client. We're going to separate it into two different pieces, and the communication will be done using gRPC. Does that sound fun? Let's get started. The first thing I'm going to do is to copy all of the code that we wrote last episode into a new directory. That way, if next video that you want to watch is the previous one, which, I do not recommend it. I'd rather you follow the normal order, but I'm a sign, not a cop. So you can do whatever you want. You can still have a look at the code, but we're going to base all of the things we're going to write on that code before. So again, if you have not watched the previous video, good time to start watching it now. If you want to continue, what we're going to do is we're going to copy all the 30 into 31 and call it gRPC and 31 gRPC. And next I'm going to open Visual Studio Code. Okay, so what we're going to do is quite simple. So basically our command, the main.go here, we're going to have server and our tool. So for now, what we're going to do is we're going to copy everything here too. So the server will serve the data. So we'll be accessing that database that we wrote, and the to-do binary will be a client that connects to the server using gRPC. So what we want to do basically is make server be a gRPC server with two endpoints in the API. And those two endpoints are the two subcommands that we had for the previous episode, which are list and add. So basically everything we need to do on this side is to modify this flag parsing and stuff by somehow defining a gRPC server and starting serving. How do you do that? That's an interesting part. So the first thing we're going to do is we're going to have to define what we call a service. So if we go here, you'll see that so far, everything we had defined was this task message. And we want to have a service, and that thing you call it, guess what? Service. We're gonna call it tasks. And what we're going to do is we're going to define one RPC message, one RPC method inside. We're going to call it list, and it gets something and it returns something. And then you can add extra things inside, like security and protocol options. I will not use any of those, but you can check the documentation for those if you really care about them. Okay, so what does list receive? And what does it return? Well, it returns a list of tasks, which is what we were storing last time. But this actually pure protocol buffers. So you cannot just say something like task. No, you need to return a message. So we're going to describe a message task list, which is, by the way, something we could have done in the previous episode too. And we're going to say that there's a task, which is tasks value 1. And the important part is we're going to say that this is repeated. So now when you do this, actually, let's ignore this for now. What happens if we create the code for this? What do we get as a result? So protoc, there you go. So this is the command we're going to be running, protoc-i dot. This is the include to do .proto, that's the file that we were editing. And then we're going to say that we want to generate Go files, so the generate Go code, and we want to use the plugin gRPC. We don't need the plugin gRPC for now because we're not doing anything gRPC related. So I'm going to keep it like this. Except that, of course, we need to go into to do, which is the one that has to.proto. So right here, now we should be able to see that pb.go has changed. We can see that we have our type task as we did before, but also we have our type task list that contains a method of a field tasks that has a slice of pointer to tasks. So we're good. This is exactly what we wanted, right? Okay, so what's next? We want to actually do something with this. What if we do not declare anything here? We just say there's a service tasks. What will this generate? This feels to, okay, so something has been auto-generated, so we should not edit it. That's indeed the case here. It recognizes that there's this do not edit, so it tells you not to edit it. But we're not going to edit it, we're just going to read it. So we have our task list as before. And now also we have our somewhere we should have a type. Oh, okay. So now this didn't generate anything because now we actually need the plugins equals gRPC, and that will generate some extra stuff. It will actually read the service message that we wrote here, service tasks, and it will generate some code, hopefully. Let's see where. Task list. Okay. We have the task client, the new task client, and a task client is an empty interface. And the task server is also an empty interface. Why is this an empty interface? Well, because this API, it's technically an interface, right? If you think about it, has no methods. So it creates an interface that has no methods. Normal. Okay, so let's start by adding the list message that we wanted to do. So we're gonna say RPC list with some message as input, returns some messages output, and as before, maybe some options, but none in this case. So what are we going to return? We're going to return a task list, that's for sure. And list, actually, we don't want to receive anything. And the way you can do this is by doing void, but void needs to be a message. So we're going to define a message void that is completely empty. So now if we do this generated a new stuff. So task server now has an interface. And this is interesting because that is the interface you're going to need to satisfy with the implementation of the endpoints. So let's do first list, and we'll do add at the end. So what we're going to do here is we're going to drop these parts, all of this part about basically deciding what to do. And instead, all of this is going to work with our gRPC, gRPC server definitions. So we're going to do gRPC, let me see, I always forget. So this is the gRPC that we want. So we're going to import that, and gRPC dot new server, and that's gonna get some options. Doesn't need any, so it's gonna get a server. That is an option. The other option is to get the definition here. Actually, let's change it to gRPC. So to do dot register task server, and register task server gets a server and a task server. So we're gonna pass the server and the task server. Okay, and what is this task server? And also, does this return anything? No, this does not return anything, but at the end we need to do serve. Serve? Yes. Into a listener. Listen on, net.listen on some port. Let's do port, and port is going to be, let's just do 888 for now. You know how to change these things, so it's not that important to actually use an environment variable. It's actually important, but we're not going to do it now. So this is TCP 888. Okay, this will return a listener and an error. If the error is not nil, we're going to panic. Well, we're going to log fatal. Could not listen to 888, and this is why. Otherwise, we're going to pass the listener here, and that returns an error. If that ever returns, we'll do log fatal. This is like when you do HTTP listen and serve, returns an error, and it will only return either because there's a mistake in your code, there's a problem in the runtime, or someone called graceful shutdown, which we're not given the option here, so we don't even have to care about that option. Okay, so what is the error here? Well, task is not defined, which is true. So I'm going to do a task server, and I'm going to define it here, task server, tasks, and just use that. And now this is going to complain for something else. It's complaining because it's saying, well, I want to use this as a task server, which is that interface we saw before that has the list method, but it's missing the list method. So let's for now just say that a task server has list. And when you call list, it doesn't do anything. This should still complain because it's saying you're actually not doing the correct type. What is the correct type? Well, we can simply go here and find it. This is the correct type. So let's copy paste. Okay, so context.context, that is indeed needed. And then it receives nothing. And then all of the options. Is that correct? Task, no, that is the client. I knew. Which one? Okay, this is the one we need to do. Sorry about that. So we receive a context. We received a void, which I'm going to call void because that is not a keyword in Go. And that's actually to-do.void. This is a to-do.tasklight and an error. That's what it returns. And let's say returns for now nil and an error saying not implemented. Okay, is this happy now? Not yet, because let's read that list context. Oh, I'm almost sure that I know what prompt this is. So we're importing context from here, but gRPC might be using this context here, which is the old one. So we're going to need to use that one in this case. And they're fully compatible, so do not worry much about that. Or at least they should be fully compatible. We'll see if this actually works. But okay, so now this compiles. That's pretty cool. All of this code below, we can ignore it for now. Everything we've done is this part. So we define a task server. We define the method list on the task server in order to have the task server actually satisfy the task server interface, auto-generated by gRPC from this protocol buffer definition right here, as you can see. And for now, it just fails. It fails every single time you call it. So let's do, what should we do? Let's run the server. So let's go back here, command server, modify the server, right? Yes, go run main.go. This is now listening. And how do we try it, right? Well, trying protocol buffers, trying gRPC is actually not super easy. There's some tools that you can use. ProtoC allows you to do it, but rather than doing that, because it would take extra time to explain how to test it, we are going to test it with the client. So let's see what the code looks like on the client now. So the client here, I'm going to remove all the parts that are related to encoding and decoding stuff. We can definitely drop them. Add is not going to do any of this. It's going to use instead, well, for now it's going to return an error. Red not implemented. Add not implemented. And list is not going to read from any file either. how are we going to fetch these things? We're going to need, where should we do that here? I'm going to pass the client here. So that is going to be to do dot client. That is the wrong one, gRPC. Otherwise, we will not get any of the new stuff. So to do dot tasks client. Okay, and we can do client dot list. It requires a context. We can pass also a context. Pass the context, and then the list pointer to void, which can totally be nil because who cares? And then on any options. And again, this for security, all that stuff, which maybe I'll do an episode on this. If you're interested, please leave a comment telling me that you actually care about something specific about gRPC, because gRPC is really large. So, well, actually not that large, but there's a lot of things we can cover. So let me know what you want me to cover. All right, and so that is complaining because is pointer to interface, not an interface. Oh, task client is task client is also an interface. Yes, so client's list should work. That returns a list and an error. If the error is not nil, we're going to return an error saying could not fetch tasks, and there's the error. Otherwise, we're going to iterate over all of the tasks. And we're going to do basically what we were doing before, and I remove all this code, which is printing the message like this. And this is going to be T. Okay, and then return nil. Okay, so if this works, what should happen is, this doesn't work because we need to pass the context. Okay, so we're going to create the client. So to do new tasks client receives a gRPC connection. So we're gonna need to import the gRPC we're using here, same one, you see. But rather than creating a new server, we're going to dial, sorry. We're going to dial to our port 8888, which is the one we're listening from on the server, and no options. We're not going to use any of those at this point. So that will give us a connection and error. If the error is nil, log fatal, could not connect to backend. And yeah, we're gonna leave it like this for now. And otherwise, we're gonna create the new client with the connection. And then we're going to pass that client and also a context.background. And this error here is being redeclared, so we don't care. Okay, so now what this does is it creates a connection to 8888. Then it generates a task client using that connection, and then we pass that with a context to our list function that will fetch it from the backend and do things accordingly. Now the backend should fail, right? Let's remember that the backend should just say not implemented, but let's try it. So if I go to command, I have server. So I'm gonna go server, go run main.go. And I'm running this, and then on this side of things, I'm going to go to do, go run main.go. And so we need to do go run main.go list. Okay, so could not connect to backend gRPC, not transport security set. Oh, we need to pass this option in order to say, so basically without this, doing things insecurely would be too easy. So you're forced to say, I know this isn't secure, but still, please let me do it. So the way you do it is on the client, right? to set credentials in the client. So when you call this new gRPC, I'm gonna do that option. So let's run again. Okay, Marshall called with nil. Oh, so you actually cannot do that. So that's kind of annoying, but let's just deal with it and say that instead of nil on our list function here, we're gonna pass a todo.void. Okay, and now that should work. Cool. Okay, so now we're getting not implemented, which is the message that we expected. So far, what we've done is we have the server that doesn't do anything yet, and the client is able to connect to the server. So the client is pretty good. The server is pretty bad so far. So let's fix that. Okay, so how do we fix that? Well, it's actually quite simple. First, we should go to the server, right? So basically what we're going to do is we're going to keep all of the things we had before. And by the way, if you pay attention to the previous episode, you will see that add and list have a little mistake, because when I'm encoding the size of the list, well, sorry, the size of the message, which is somewhere in here, when I'm encoding binary.write endiness of this, on the previous episode, I was doing gob.encode, and that causes a little bit of a problem because gob.encode doesn't really use the same amount of bytes to encode what I wanted to encode. So it's important to use the simplest tool that works. So that's why I moved into using binary.write, much easier. Okay, but if you don't know what I'm talking about, that's fine. That's from the previous episode. So what are we going to do on list here? Well, that's pretty much what we're going to do, right? Like this list method here, going to move this a little bit down, and list is going to be something like this instead. So we're going to drop this. We're going to read from db path. What is going on? Something is not happy. I don't know what it is. Binary, undefined binary. Somehow. Encoding binary. Yeah, gofont is not even running. Let's figure out later. So, as I was saying, we're going to do is we're going to adapt the list function that we had before to be a method of the list server, of the task server. So, rather than returning this, we're going to return nil and this, nil and this, nil and nil. That is a task list. So actually we need to return an empty task list, because then the slice inside is nil, which is fine, but returning a nil task list might not be okay. So you're going to return an empty task list that. It's going to be nil, this is going to be nil. And the important part here is that, so we're going to be doing this for loop. What we're going to do is we're going to have var tasks, which is of type to do task list. And we're going to return, whenever we're done, we're going to return tasks and nil. Sorry, a pointer to that. Otherwise, whenever we get a new task, we're going to add append tasks.tasks. Wow. Task.tasks append task.tasks of task. Woo. Actually, pointer to task. I will not read that again because there's many tasks. Probably naming could be better in this case because I repeat myself a little bit too much. Tasks. Whew. Okay, so we append that and we don't print anything, and that's pretty much it. So if you don't know what this code is doing in detail, watch the previous episode, because the important thing here is that basically we're able to adapt what we were doing before, and just rather than printing it, returning a task list. And that's pretty much it. So let's try it. I'm going to run my server again. And this is not happy. OpenMyDB, no such file or directory. And I guess that makes sense because we should actually access the, so let me try, go run min.go -h. I don't think we have any flags to control where the database is stored. Oh, and also that doesn't work at all because we don't have any flags. Okay, so what I'm going to do is I'm going to install this. I'm going to build it here and then move the server 2 levels down. So now I can run the server here, and that should work because now I will be able to access the mydb.pb, which is what it's looking for. And there you go. So now you see those lists, we actually fetched those from mydb.pb, and it's the server binary that is retrieving them, sending them through gRPC back to the client, and then the client receiving them and printing them. The printing part is here. So it's pretty simple, just iterate over them. Cool, so now we're gonna finish by adding the last method, which is add. So how do we do that? In this case, it's actually pretty simple. We need to go here and I'm going to say that since we're passing on a string, I'm going to do a new message. It's gonna be message text, which is a string, has string text equals 1. So when you add, you're gonna add some text and it's going to return a task. Okay, so let's run it again. Protobufs. Actually, I need to go back to do and protobufs all of that thing. Not happy to do the proto. Oh, because I'm totally in the wrong place to do. Okay, and protobufs. Okay, so now let's watch. Let's have a look at that auto-generate thing and see that our type task server has now 2 methods. One is list, which is the one we already implemented. The other one is add. So what we're going to do is, I'm not gonna change anything, don't worry about that. We're gonna go back here, and if we save this, normally it should fail now because task doesn't satisfy the interface anymore because it's missing the add method. So let's add it. I'm going to do pretty much the same thing as I did before. So I'm going to add this as a thing and comment all of this stuff. And so that's going to be our task, and this is going to come from, so that's context, and this is text. That's going to be text.text, to-do.text, and it's going to return a to-do.task. Okay, so now we have the task. If something fails, return nil and the error. Exactly as before, we don't change anything there. The only thing we're going to change is that once we're done, we're going to return the pointer to task and nil. Except that is a task. Oh, okay. So that's already a pointer, so we don't need to do anything else. We just can return that. So now everything works again, and our server has go build. So go build command server -o server dash. No, really? That you're not happy with that server? Oh, because -o server. Okay, that way we'll compile it here. And now when I run it, this is a new version. So you could imagine that since there's a new version, I should also need to recompile or whatever the previous binary or change something. And actually, no, you don't need to change anything. It's binary compatible. So if you run the message again, it will simply work. Even if you had compiled it and just run the server, it would still work, which is pretty cool. So, and that's the whole point about protocol buffers and gRPC, is that migrating is actually pretty simple. Okay, so let's finish by adding, so if we do add, this should still not work because it's not implemented. So let's do that part and then we'll give the episode as done. So how do we do that? Well, we're going to pass, as we're doing before, the context, the task line, and the text. You're going to do client.add context. The text is going to be to-do.text with text inside. So text is going to be text. Feel like I'm repeating myself a lot today. To do text. And what else do we need to pass? Nothing. And that's going to return a task and an error. If the error is not nil, could not add task in the backend. And otherwise, we are going to simply print the task saying task added successfully and return now. Okay, so as the last test, we're going to do go run main.go add. And it doesn't work because we have string and we are not calling the function correctly. So we need to actually pass context of background and client. And that's better, I guess. What is your problem now? T-declare and not used. That's okay. We don't care. And that's it. Okay, so let's try it one more time. So we're going to build, we're going to run it. And when I run add task added successfully, and that's a problem because it's going to be empty, but that's maybe okay. Something awesome. And something awesome was added to the tasks. Cool. So this is a good place to start. There's way more to do. So if you want to do, why don't you try to get the code from github.com/campo/justforfunc, which it's always linked in the description of the video, by the way. And you try to add something like how to mark the task as done. That sounds like a good exercise. And if you have issues, leave a comment and maybe some of the people or maybe myself will be able to help you. So this was the end of the episode. This gave you a little bit of a better idea of what gRPC is for. I didn't want to get too much into the details because there's a lot to learn, but let me know what you want to know more next. There's things like Cobra. I'm actually working on a Cobra episode because there was a lot of comments on I want to learn Cobra from the previous video, so don't worry, I heard you. But there's other things like maybe you want to know about how to expose this as HTTP. There's a magic project that does this. Or so basically you get a REST API for free with a gRPC API. Pretty sweet. Or maybe you want to do like bidirectional, not bidimensional. That'd be cool though. Bidirectional streaming. So basically both the client and the server can send messages the other way around, right? Maybe that's what you want to do. I don't know. Please let me know, forum.justforfunc.com or on Twitter, I'm Francesc, or just simply leave a message here and I will read it for sure. As always, thanks so much for watching. Please subscribe and see you all in 2 weeks.